Study Group. This is our third ever study group. We are trying something, something different in the Women Who Code group here. And just for some of you who are new to Women Who Code, our mission is to inspire women to excel technology careers. And we support women with their, not just their technology careers, but also different roles that may or may align with their technology careers, right? And I'm your host and presenter, Prachi Shah. I'm a senior software engineer at Microservice here in San Francisco. And I have been in the industry on and off for almost a decade now, mostly focused on backend engineering role. For tonight's session, we will discuss design patterns. Since software design patterns is a big subject, there's a lot that goes into it. We decided to have like a mini series for it. So our first session will talk about creation design patterns. Then we'll move on to structural and behavior for respective sessions. This is because there are 3 different types and they are huge in themselves. There's a lot to talk about. And since we are talking about design patterns, I think it's only fair to talk about anti-patterns. This will involve some design principles as well. That will be our 4th session. And after that, we'll do a session just for interview questions. This is including coding, any theory questions in general. We also have created a GitHub repo. Here is I've added a link to this, which is the repo for the Backend Study Group. We are trying to have a code repo as an example with every session. And this GitHub repo is where we update or we upload all the code. And for today's session, we have created a demo code, which is also uploaded in the repo. If some of you were not with us during our last 2 sessions, here is the link to the YouTube recording. The first one was on March 25th, and the second was on April 8th. In the second session, we talked about, we did a demo of creating a microservice in Java and building REST APIs for it, and also building like an in-memory H2 database, so to support the whole to support cloud operations. And related to that code, I have uploaded screenshots of the Postman API calls, screenshots of the database, so you can, it's all uploaded on GitHub, so you can go and refer to that. Today's presentation I'll also upload on GitHub, so you can refer to the presentation and all the links as well. And thanks, Elaine, for sharing the link to the GitHub repo in the chat. We also have at Women Who Code, we also have other technical tracks for data science, front-end, etc. Do check them out if you're interested. And also any upcoming digital events, if you're interested in, here is a link for all upcoming events. And if you are curious about what we do at Women Who Code, sign up for the mailing list. Towards the end of this session, we will share a survey. We want your feedback and your ideas because as you can see, this is the 3rd Backend Study Group session, and we are trying to get better at what we do. And also, if any topics that you are interested in, do share that in the survey as a feedback. Just a bit more about today's agenda, very quickly. We'll talk about backend engineering. That's what the study group is about. Just very briefly what that means. Also, we'll try to understand at high level, what does design mean here? What does software design mean, right? Because design patterns that I'm going to talk about are more object-oriented focused. Therefore, I'll just revise some of the object-oriented principles using Java as a programming language, because that will help understand the patterns in a more structured way. We will also talk about the definition of what design pattern is, the 3 major types of design patterns, and one of the types is creational pattern, and we'll talk about top 3 creational patterns which are much more used in the industry in general. And then we will have a Q&A. I also mentioned resources that I referred to for this event, and also had First Design Patterns book. I would recommend that as a good book to get started on design in general. So let's quickly talk about what backend engineering is, right? So it is something that users don't see, right? For example, you and I as a user, we see a mobile app, we see a website, but how is that website getting data from? How is that website collecting data and processing it? We don't know what goes behind the scenes, right? So everything that's behind the scenes that the user cannot see is what is considered backend engineering. And the designing of softwares, applications, systems, building them, actually developing them, maintaining them, scaling them, all of this is all considered backend in general. Some concepts that are very basic are client-server architecture, client being your website or your mobile application, which consumes your data or which is the entry point for data into your system, right? That can be considered a client. And server is, here I would say it's vaguely used because server is a web server. It can also be your microservice. It can also be database. It can be a bunch of other things that go behind the scenes for you to build an application, right? So, but generally a client consumes the data or captures the data in the server, and everything after that is what processes the data, the business rules, the logic, data validations, data storage, all of it. APIs, application programming interface, I would say it's kind of contract between your front end and your back end for data transfer, data collection, data validation. So most applications, microservices have APIs for consumption. That is the contract for communication between two services, between two applications. Microservice is a term used in the context of like applications in general. You can create an application which does 10 different things, but it's hard to maintain that application. It's hard to test that application if there is a bug, or if you fix some bug in one part of the application, now all of the rest of the code may be affected because it's all so tightly coupled and connected. So microservices help us modularize these functions into separate applications, which are loosely coupled and communicate with each other over APIs. Database engineering, almost every application deals with data, right? Gathers data, shares data, processes the data. That's where database engineering comes into the picture on the best protocols to design a database and store your data. How do you structure your data? How do you communicate it? How do you validate it? How do you sanitize it? All of it. Some other things to keep in mind, I would also say are, when it comes to backend, it can be like monitoring your systems, deploying your systems, scaling your systems. All of that would be also considered backend engineering in general, as a big domain has all these small pockets or subdomains in it. Now let's talk about software design. In order for us to build better applications that are scalable, that have good performance, that leverage their system resources in the most efficient way, have a clear and simple intercommunication, have a structured way of gathering, storing, processing data, we need to come up with a design, right? Like a blueprint. Before you build something, you create a design where you identify different systems, where you identify different data entry points, where you identify dependencies, right? So using an effective design, I think coming up with an effective design is the most valuable first step to begin. And in order to do that, like I mentioned, you have to identify the modules, the interfaces, the structure of the data, and the whole interaction in your entire system. Right? Usually when you build an application, you are either solving a problem, right? Or you're building a new product or a new feature. So that's the motivation or the goal of a good design, that you build systems to either solve an existing problem or to build a new product feature. Like I mentioned before, if you get into more details of the design, you have to think about what the input looks like to your system, different inputs, right? It can be through API, it can be through mobile app, it can be through a website, right? So you have to define the inputs. Your system can process 3 different kinds of data. One data you store, one kind of data is relational data, the other is non-relational data. Your system is able to process them, right? So you have to define the input, you have to define the output as well. Does your software has no mobile app or no website application, just has APIs, and that's what is your output or your entry exit point, right? You have to define that. Business rules would be like, let's build, for example, let's build a banking application, right? Your business rules will be around like, we need to create accounts, right? We need to ensure the security of the user data, right? How are we doing account management? How are we doing money management? All of that comes, what are the banking policies and laws that I need to keep in mind? So there is this overlap between the domain and technology, where that's where the business rules come into the picture. And then data schema, which is what I mentioned before. You have to define how your data looks like, how you're going to store it, how you're going to index it, how you're going to scale it, right? If your application changes 2 years down the line, is your data something that can be modified, your schema, or you'll have to create a whole different data solution just to store and process? Some of the things to keep in mind as you think about designing. There are some common design patterns that solve some of these problems for us, which we should talk about it later. But 3 kinds of designs, very high level, is to keep in mind. There's a data UI design, right? So data visualization and presentation. Your application is very like customer focused, right? Like your website brings in revenue. So you want to provide a best user experience ever, right? So in that case, all your design would, and the way you build your system would be focused on providing the best user experience. Right, so that would be your product, right? Like you want to provide the best, the most simple and intuitive website, and with the best user experience. So that would be your goal. Your design would be very UI heavy. Next would be data design, right? So let's say you build an application which stores data on the cloud, right? You don't care about whether that application looks super pretty or super easy to use. You want to make sure that the data you upload to, let's say, on the cloud is secure. You can upload a lot of data in petabytes, and your software, your application should still be able to support that, right? You want to use the most efficient storage. You want to use different systems for storage. It can be distributed data storage. There can be cache, a bunch of other things involved. So your design would be very data heavy. You would not focus on the best UI, but you will focus on the most efficient way to represent and store your data. Other is process heavy. So a good example here would be like, again, banking application, right? There are heavy business rules around like security of the data, how we are storing the data, who has the access to that data, right? How are you authenticating a user? How are you authorizing, right? What kind of security measures are in place? You may not have the best UI for this, for someone to log into their banking app. You may not need to store a lot of data. It's just transactional data and your balance information, right? So it's not super heavy. It's not like you're not storing images and files and movies. It's not a lot of data, but your business rules are really heavy, and the process around it is heavy, like what kind of validations you do on the data, how are you manipulating it, what are some of the features, right? Banking features that you provide. So all of that comes under process. And as you think about designing applications, the architecture of it, you not only think about like, I have a standalone application that has one function, right? You have to think about that first, but you also have to think about like the overall architecture. What if your service is utilized by some other microservice, right? What if we are building more and more products, more and more features, and your application, it goes out of the scope of your application, then you might have to create another microservice just so that these two microservices communicate with each other to achieve a common goal. So you have to think about like distributed systems. Think about like, how will the data storage be? Will these two microservices use the same database table to store the data, fetch the data? what would the performance be? Do these systems need to be deployed together to support the feature, or they are not that tightly coupled, right? How can we monitor them? If one service goes down, then the product will not work because that service is not available, right? That can cause all sorts of failures and errors. So some of these things, this more aligns to system design, but some of these things to also, in general, keep in mind as you think about software design. A quick refresher on object-oriented principles just for today's session. I'll talk about very basic theory of object-oriented programming and a quick demo. We'll look at the code. And then we can talk about design patterns, because when I demo the design patterns code, because you know about this, understanding that code will be very, very simple. So object-oriented programming are basically a set of principles that help us create and define different objects and functions. So in the object-oriented world, you create classes, and they have objects. So class can be considered something like a template, which has data and functions. So for example, a person is a class, and a person has a name and age, and a person has different functions, right? A person can walk, a person can talk, a person can sleep. So that's how you should think about designing a class, in the sense that it's somewhat a real world entity which has some data points, and it has some functions or operations or methods around it, right? So this allows us to structure code, reduce repetition, and it helps scope your entities, your objects, your applications in a very, very structured way, which will help you eventually maintain them, scale them, add new features, add new data points, add new functions and methods. One of the best benefits here, like I mentioned, is don't repeat yourself, right? If you structure the data in this way, changing the code, maintaining the code, debugging, testing, becomes much more structured, much more intuitive. So we already talked about class, right? It's like a template which has some data points and some functions that will do on those data points, right? An object is an instance of a class. So one class is like a template, and object is multiple instances of that class. So if you look at the diagram to the right, I have a class called shape. And so shape will have like different fields, right? Like it can be length or breadth or radius, something like that. And I will have functions like get area of that shape. But we'll look at that example shortly. But my shape is like a core object, core class or a template. And object is different instances of that shape. So using that shape, I can, basic shape class, I can create a rectangle shape, I can create a circle shape, I can create a triangle shape. And the objects are what are used for data manipulation, for data gathering. Class is just a template. It is loaded when the program is run or executed the first time. And then you can create as many objects, right? As many shapes using that template. And how you define the shape, the data points and templates, data points and functions will be common across all shapes, right? So like area, if I have a data point in shape called area, it will be common across area of rectangle, area of circle, area of triangle. Calculating the area per shape is different, but just that all these objects share the same attribute and method of the class shape is what object-oriented it's what object-oriented programming is about at the very basic. So if you look at the example, the code example to the left, what I've done is I have a class called hello world, and it has a data point string hello, which has I have initialized that variable or that attribute with the text hello world. And in the public void, static void main method, which is the entry point for a Java program, I am creating an instance of that of the hello world class, which is hello there. That's the name of the object. And when I print hello there.say hello, what that method is doing is it's just printing the data point, which is hello world. So at the very last, you see that's the data point that I printed using my method say hello, which is a part of the object hello there, which I created, right? I can create hello there, hello here, hello where, anywhere, whatever. I can create different objects and print the same thing, or I can print something different. I have all that control over how many times, given my template hello world, which has one data point, I can create as many objects and print as many hello messages, right, that I want. I'll quickly shift the focus to the code. Can you see my screen? Can you see my screen? Okay, I got a thumbs up from Sally. Thank you. Yeah, so, okay, so I will, this is the hello world example, but this is what I did, right? So if I run this,
Prachi?
Sorry, can you repeat that, Aditi? Oh, I see.
The font is a little small.
Yeah, thanks for bringing that up. Let me increase the font. Is this better?
Yes.
Or okay, good. Sorry, the left-hand side, I cannot increase the font. That's the structure of the project. But this is the code, right? Like if I say hello, I don't know, Susie, it's gonna print hello Susie, right? Because I'm just gonna run the code. Did it run? Hello Susie, right? So I can even like define different data points here, right? And they, like, you say hello or you say bye, and what this method does is it will print Susie, right? So if I do this, if I say bye, then my method will print a bye as well. Simple. I'll quickly go back to presentation. Some basic stuff just to help with the ID is IntelliJ. I'm just responding to the chat message. Quickly, just a few things. In object-oriented programming in Java, in classes, we have something called a constructor, which is basically that's how we initialize the attributes or the data points of a class. It is called when objects are created. You can come up with custom constructors as well to initialize one or more fields of the class. Or initialize the fields or attributes at the very basic level. We'll look at this a bit later. Just some examples of constructor. Just to keep in mind that the name of the constructor matches the class name. It doesn't have any return type. And like I mentioned, if you don't specify a constructor, you get a default constructor, which initializes the default values, right? For example, I had string hello and string bye. If I don't have a constructor in my class, when I load this class, the hello world class, it's going to initialize them to string hello is equal to null and string bye is equal to null. The program will do that for me. Or if I have a custom constructor where I define, every time I create an object of this class, it should set the value of hello variable to hello world and bye to bye world. It's going to do that every time any new object is created. So we have that power of control over how we want to initialize different attributes in a class using constructors. A few things to keep in mind is also access modifiers, right? Private is where your data point, your attribute, or your method is only visible in your class. Public is where it's visible anywhere. Anybody, any class or any program within your application can see your data points in a class and also can have access to those methods. And protected is where the data point and the attribute and the methods are only visible or accessible to the same class, subclasses, or the package. I will talk about this a bit more later. Just something to keep in mind as we look into the code later on. Some basic principles of object-oriented programming. The reason why I have to mention these, it may seem like a Java refresher course, but the reason why I have to mention these because our patterns are all dependent on these principles. They leverage these core principles for the template solutions that they are. So just doing a quick refresher of these concepts and quickly looking at the code will help you better understand patterns in general. It will also help you come up with a way of thinking, that this is how you think about object-oriented programming. This is how you think about design. This is how you think about design patterns. This is how you understand them. So then with time, you'll understand that this is the product or feature I have to build. And according to that, this is a design pattern that I would use to solve my problem, right? So understanding these very basic principles is key. So there are 4 types of object-oriented principles: abstraction, encapsulation, polymorphism, and inheritance. If I quickly look at abstraction. So very basic core principle here is abstraction basically helps you hide the complexity and details of the class, of the implementation, right? Your class has attributes and methods that operate on those attributes, right? And if you have a calling class which calls your class to get the data or add the data, it doesn't need to know the details of what your class does with that data, what operations does it have. All it knows is that these are certain operations that happen on the data point. Each class can have its own abstraction, right? It's not something that's every class doesn't have the exact same abstraction. Every class has its own purpose, has its own kind of data points, so it will define its own abstraction, right? This helps to structure the code properly, right? You scope it out and you structure the code. It also helps you maintain the code and add new features. So if you look at the example to the right, the person has a name and age. Oh, my bad. The person has a name and age, and then there are operations on those data points, like get the name, get the age, get the salary, right? And this person can be of type artist, can be of type chef, and can be of type doctor, right? So my person class can be extended for 3 different types, and each type has its own more data points and more different methods, right? And how the salary, let's say if you see get salary is the same across artist, chef, and doctor, how the salary is calculated may be totally different for 3 different types of classes here, right? So if I have to add another field in doctor, let's say let's say they retired, or their status, right? Like are they active or not? If I want to add that field, then I can totally do that without changing any other classes that are calling my doctor class. It should not break anything. I can totally add features. I can totally remove features. Another real life example would be Instant Pot, right? Instant Pot is I don't need to know how Instant Pot is cooking the food, right? I don't need to know what different functions on the Instant Pot are. All I need to know is if I press this button, it's going to do the job for me, right? If I'm cooking a rice, I just have to press that setting. How it's cooking the rice, depending on the quantity and the water and everything, is its own function, right? I don't need to worry about what that implementation looks like, right? The implementation is hidden. Same as another example would be like a coffee making machine, right? An espresso machine. I don't need to understand how the coffee is made. All I need to know is just select the settings and add the water, and that's all, right? And the coffee beans, and the machine will do its job, do its magic, and give me coffee. How it did it, I don't need to understand that, right? So that these are some good real life examples. Some of the way abstraction is in the code level achieved is we have like getter and setter methods. So if you see, I have a name and an age. These fields will be private in my person class. And how can a calling class or another class that I have a relationship, that where there is a relationship in these 2 classes, is going to get the name and age is through get method and get age, get name, get salary. Setter methods are when you want to set the name, the age, the salary, right? So getter and setter methods help you operate on these private data fields which are part of the class, right? One other thing I already mentioned before is like salary, right? The implementation can be different. The way salary is calculated for a doctor will be different from a chef, will be different from an artist. The implementation can totally vary depending on the business logic, right? But just that every class has its own data points and its own abstraction on getting data, setting the data, and doing some business logic around that the data points in that class. We have more control over all of that, and this is all structured. Everything related to the doctor is in the same class, and getter setter methods help other classes communicate with the doctor class to get the data, set the data, do some functions, apply some business rules. This is where you would want to apply some business rules, if at all, which are very close to manipulating the data. We can look at a code example. So here is my person class. Here is my person class, which has a very basic name and age. And this is my constructor, where whatever field, whatever data points you provide me, that is what I'm going to set here for every instance of this person class. Every object created for this person class, I can specify the name and age. If I don't specify it, it is going to set it to none. Right? These fields will be initialized, but they'll be set to none. Very basic. And then I have my get name and set name methods, which I can, given an instance of this class, I can change these fields, right? Here is my get salary method. Right now, I'm just printing that the salary is so-and-so, but there is totally possible that there are more fields in this class, and you are actually doing a proper mathematical calculation to calculate the salary and return it for this particular class, right? If we look at the artist class, right now, there are a few more fields in the industry in which the artist is working. They can be a painter, they can be a sculptor, they can be a singer, right? They are still all artists. The industry may differ, and the location that they are in is what we want to capture here. But because this artist extends person, then we can also set the name and age. I'll talk about what extends means a little bit more, but if you see, because artist extends person, I can also set the name and age for this artist, right? This is how I am leveraging an object-oriented principle here that of basically inheritance. We will talk about a little bit more, that you are setting all of that for an artist. And then getter and setter methods, and the salary for an artist is, let's say, 50,000 a year, which is different from what it was for a person. If we quickly look at doctor and chef classes as well, they have different data fields. Chef would work at a restaurant, and the location of that restaurant, and his or her salary is slightly different. In the doctor class, we are looking at the attributes are department and hospital, location, city, and getter and setter methods, and the constructor, and the salary may be slightly different than, let's say, a chef or an artist. So when I run my so here, when I'm creating an instance of the artist class or a doctor class or a chef class, I can set the name and age, I can set the industry, and I can set the location. And this is how I'm instantiating the objects for these respective classes. And if I just print all this data that I've created, it's going to print for me that has so-and-so age and has so-and-so salary. And here, I also created some more objects of the same class, right? Previously, we had artist, doctor, chef. Now we have new artist, new doctor, new chef. So then I've added more details. And if you see that I'm printing the name, the age, they work in so-and-so department, in this location, and this is their salary. So I'm using the get salary method to also print all of that data. So this is how data is structured in a class typically, data points, and then getter setter methods for abstraction. So other classes can also have access to these data fields, and you can add some more methods which actually properly operate on the data, more specific functions on the data per class. We can quickly look at encapsulation. This is somewhat similar to abstraction in the sense that, yeah, we are bundling the attributes and methods in one unit, which is a class. You want to create, whenever you're designing a class, you want to create it to more like a real world scenario or real world entity. like a person or a doctor, an artist or a chef. That's more because everything you create, most applications you end up creating are solving real world problems, right? So that's what you want to your class or an entity to create. This, if you bundle your data and for accessing that data, you create all these methods and you're hiding the implementation of those methods and the way the data is manipulated in that class. The calling class doesn't need to know how you're calculating the salary. Just give me the salary for a doctor, right? That's all I care about. Like I mentioned before, getter and setter methods help you access the data, and this way you're scoping out data points and what functions you want to do on those data points. How much control do you want to have on that data? And going forward, you can add more and more functions, more and more operations on that data, right? So you have all that control. It's like much more structured. This also helps you secure your data. Like, for example, not to the right, like let's say I have a chef class, right? Nobody needs to know the age of, no calling method needs to know the age of the chef. So I will never add a get method for get age method for a chef, because nobody needs to know that. I'm only collecting the data for some data analytics or storing that in my database for other reasons, but I will never share that age data with anybody else outside of this class. So I will never have a get age and a set age. I will have a set age, but not a get age class. So nobody has access to the data at all, right? So you can improve the security of your data with just using different methods, right? So again, like data can be read only or write only, right? You can only write the age, like you can set the age, but you cannot get the age, so you cannot read it. Or you can only read the rate of the hourly rate of the salary rate of the chef, but you cannot set it. So I will not have a set rate method. I'll only have a get rate. You can only read that. Read the rates of a chef. You as a caller, you don't have the authorization to set it, so you will not be able to. But if there is another application that is able to set the rate and get it, then you can. Then there will be different way of structuring the chef class to set the getter and setter methods. Inheritance, I think, is one of the most important principles as well, where a class you can derive a class from another class. So it establishes some kind of hierarchy of a superclass and a subclass, where if you see a person is the main class or a superclass, and it can be of 3 different types. A person can be an artist, a person can be a chef, a person can also be a doctor, right? And a person class has defined 3 functions, 3 data points, name, age, and salary, and let's say 3 methods. So if you're inheriting a superclass or a base class such as person, you will also inherit all their functions. So artist, chef, and doctor classes will automatically have all these 3 methods for use. They can also have their own methods, separate methods, more methods which are different from person. Artists can have some functions and data points which are different from that of a chef and a doctor. But if you want some kind of code reusability, then inheritance is something that is most important. You want to create a base class with base data points and base methods which apply across all different subclasses or types of that class, right? We use the extends keyword. So if we look at the code quickly, my artist class use extends person here when I define the class. So everything that the person has, name and age, I'm able to get those data points, right? So when I'm creating a constructor of the artist class, I'm also setting the name and the age, because I've extended the person. So every artist every instance of the artist I create, I can set the name and age. Same with chef, right? I am extending the person class. So every instance of chef I can create, I can set the name and the age, right? So this is code reusability. This is we are not adding name and age and all those methods per chef, per artist, per doctor class, right? It's there in one place, person, and we are just reusing it. So this is most applications will have this kind of a structure. For example, users, right? Your system can have 3 different users. Employee, your university can have 3 different or 4 different types of employees, right? They all have a salary, they all have a name, they all have an age, they all have an address, they all have an employee ID. So that can be something that can be very common. and each employee, the way the salary is calculated, let's say it's different. Some are hourly, some are, some are 40 hours, some is something else, right? You can define all of that, you have more control. The last and the least one is polymorphism. This uses interface for different classes. So what happens here is that in the same example, right, you can, let's take the example of get salary, right? That method or that function is available for all the different type of persons, but the way the salary is calculated will be totally different. But because you have the same functions on any kind of person, you can define an interface class with all these functions where the definition of their function, of that function or implementation can be slightly different per type. It uses an is a relationship where, if you think about it, artist is a person, or chef is a person, or doctor is a person. That's the way you have to think. That's a relationship that is defined here. And interface basically has so you need to define an interface rather than a class, which has all these methods declared, and every class that implements this will define those methods. Things to keep in mind is any methods you define in interface, they have to be all of those methods have to be implemented by any class. So artist cannot just implement get name and not get age and salary. It has to implement all the three. Same with chef, same with doctor. And like I mentioned, the way age is calculated for an artist may be different from chef, from doctor, or the way the salary is calculated will be different for all different types of persons, right? So if we quickly look at the code, yeah, right here, right? Like we have this, let me, one second, let me, here, this is an example. We have a shape which will have a name and a formula. This applies to any kind of shape, right? So any class, let's say rectangle class, implements the shape. It has to implement both the methods, and it has to come up with a function of how the logic around both these methods. So it will implement get name, get area formula, and the logic here in all these methods can be different, right? For example, circle also implements shape. So it has to implement get name and get formula, but the name here is different. The way the formula of the area of a circle is very different, right? So this is what helps us maintain the code in general. If you add a new, let's say you add a new method here, which should apply to all the shapes. It's really simple. Just add one method here, and then because all these shapes implement a shape interface, you will add that method here, and in rectangle, circle, and triangle, and you will have 3 different implementations of that method, which are very specific. So this way, if you want to have a similar behavior over time on certain type of objects that are similar, this is where you use interface, and this is polymorphism. So like, you still have the same method name, but its implementation looks different. You still have the same method for calculating, for finding the area, right? But the value of that area is totally different depending on what that shape is. So this is what polymorphism is. It's the same name, but the implementation looks totally different. Yeah. Okay, now let's talk about design patterns. What are design patterns, right? Like, these are like set of templates or solutions that can be reused, right? These are some standard solutions to some standard problems, right? And because design patterns are some like a template, you can use the same template or the same pattern for multiple applications, right? So you have the shared vocabulary. Like if I tell you that let's talk about builder pattern, then you will know what I'm talking about or where I'm getting into. If I tell you that this is my problem, and I think builder pattern is going to help me solve this problem, then you will kind of know what I'm trying to say. How am I applying this template solution to solve my problem or to build my application, right? So these are some basic templates that you can begin with. to design some common applications, to solve some common problems. And then depending on an application, you can build on top of this template design, right? You can use a bunch of different patterns that are required to do some different things in your application, right? So like I said, design patterns are some standard solutions. So they help you write better code, which is more maintainable, which is more reusable. It's easy to scale, like we said, right? If you want to add a new method to shape, you can just add that, and all your other all the rectangle, triangle, circle, all the shapes will also inherit that, implement that method in their own way, and it's just easy to add that new feature, right, across all your shapes, because it's something that would be common. Just to keep in mind, it's not like a library or a framework that you can just add to your code. It's more like a principle. It's more like a set of recommendations that you want to apply for restructuring your code in a good way, for trying some of the basic coding problems, trying to reuse your code, right? Trying to implement features or new code changes in a more structured way. It's easy to maintain, debug, test, all of it, right? So you, like I mentioned before, you can adapt a pattern or two, or even different patterns if the application is really huge and solves different problems. You can do that, and you can improve upon it to fit your application, right? To solve a problem or to build more features, you can start with this baseline and build on top of it. And like I mentioned before, these design patterns leverage object-oriented principles to structure the data to provide more flexible and maintainable designs. That's why quickly looking at object-oriented principles, I think, is essential. If you think about design patterns, mostly they are Java design patterns, object-oriented programming knowledge. Even the very basic that we saw will just help you understand the patterns properly. They'll help you pick the right pattern to solve the right kind of problem as you're designing your applications. Now, I think you know at this point that these patterns or these recommendations help you define different relationship between objects, create loosely coupled objects, also secure objects. This is basically defines the relationship and communication of all your classes and objects across your application. If we look at quickly the different kinds of design patterns, the three major: creational, structural, behavioral, and each of them have their own different types. Some of them operate at the class level, and some of them operate at the object level. So like, for example, a factory method or factory design pattern helps you structure the classes properly, whereas abstract factory or builder or singleton are more focused on creating the object in specific ways, right? Same with structural and behavioral. Structural, we'll talk about this just like in the next slide. So three major types to classify. Creational is the first one. This focuses on how you are initializing a class and instantiating the objects, right? So how are you creating, given a class, right? How are you creating different objects of it? And for each of this object, how are you initializing the data in it, right? So for example, a person, we looked at the diagram, right? Person and artist. Given a person class and artist class, how are you creating different instances of it, and how are you initializing different data points on each of these classes, right? You can create an artist with no age, or you can create which is one object or one instance of the artist class, and then there's another instance which has name, age, and salary, all of it, right? So you have control over how many objects you want to create for the artist class and what all data points are you initializing. If you only initialize the name, the age and salary will be null, the name will be set. So you have more control over how you want to create these objects and define the classes. This helps decouple the creation logic from the implementation, right? So you can create three instances of the artist class. One artist class represents a sculpture, other a painter, and other, let's say, an actress. And the data points on each of these three types of artists can be different, and the functions on them can also be different, right? So you have more control over what that implementation looks like from how you actually created 3 different type of artist classes. The 3 examples, we are looking at 5 types: Singleton, Factory, Builder, Abstract, Factory, and Prototype. In today's session, we'll only look at Singleton, Factory, and Builder because they are the top 3. Factory and Builder are pretty much used everywhere. So we'll just focus on these 3 creational patterns. If you quickly look at structural, they are more concerned with how the class is structured, what the composition is, how can you create a structure of a class for better usability, for adding more and more functionality on the data. And at a high level, you create large relationships between many different objects of different kinds. So adapter, facade, decorator, composite, all different kinds of patterns to structure your class and your objects. And behavioral is more related to the behavior, the relationship, the communication between different classes and different objects, right? So observer pattern, strategy pattern. Let's say there is, you have a weather app, right? You have a weather service for San Francisco, and the rain is predicted in the next 1 hour. You got to know that, the weather service got to know that. So every consumer of that weather service, every mobile app, now as a consumer of the service, all of them will be sent this notification that, oh, there is rain detected in your area in the next 20 minutes or next 30 minutes, right? Like different objects created now, right, for each mobile app, each implementation service, and you kind of define that relationship, that communication, on how data is shared, how classes and objects are structured. Any questions so far? Okay, we'll continue. So the first kind of creational design pattern is Singleton. Here, what we do is we only create one instance of a class, right? So, for example, a company can have only one CEO, right? A university can have only one proctor. So if you're creating like a CEO class, you can only have one instance of that class. So if you're creating like an application for Lyft, right, the organization structure of Lyft, you'll only have one class or one instance of the CEO class, which is you are a CEO of Lyft. That cannot be more than that, right? So it's only one instance of a given class. And as you can see in the example, CEO class has one instance, which I name CEO of Lyft, and it has its own data points and it has its own methods, right, on that class. Because it's a Singleton, we will only create one instance of that class, and we'll call it static. So it can be used every time the class is loaded. We have that one instance to be used. We create a private constructor rather than a public constructor, so that no other class who has access, who knows about this class in your package, can actually create more and more instances. Because it's private, the constructor or the initialization only restricts to that class, not any other classes, right? Typically, there is a get instance method which returns that instance, and that instance here is an attribute in the class. There are a couple ways to initialize such a class. One is the lazy initialization, where only if I'm calling a class, at that point I'm initializing it, right? So at that point I'm doing an object creation. Whereas eager initialization, where my object is already created, and when you call me, it's just you just have it, right? A real life example would be log4j, which is a logging program in Java. You define it once per class, and even if you have many instances of the class, it's just one instance of the logger for that given class, right? For logging everything in that class. So here, if I think about code, I'll create an instance or object of the CEO class. I'm going to name it CEO of Lyft, and it's just going to return me the CEO instance, right? So if we quickly look at the code, Singleton class. So I have 2 different kinds of examples for Singleton. One is the Singleton Initializer, which is the lazy initialization, and the Singleton on demand, right? So let's look at the on demand first. what I'm doing is I'm defining an instance of this class. It can be employee or person or actor or artist, whatever your entity is. And I'm not initializing it. It's set to null. When I call the get instance class is when I'm actually creating a new instance of this class and I'm returning that instance, right? So this is on demand initialization of that object creation for this class. And the other is a lazy initialization where, an eager initialization where I'm creating an instance of that class, and every time you call the get instance method, you already have that instance created, and I'm just going to send it. So if I look at the code here, I'm calling both of these classes, I'm creating instance of both of these different types of classes. And if you see, the first one is initializer class load. So it's a singleton eager initialization. And this is what my object, the hex of the hash code, object hash code looks like. And this is another instance where I'm creating it on demand, and it's a different object altogether, right? So this is very basic, simple way of creating only one instance of your class, either in an eager initialization or a lazy initialization way. These classes don't have any methods, otherwise I would have printed that as well. You can easily have more and more methods, and the only one instance that you've created will have access to those methods. We can talk about factory. Singleton is not used a lot. Very few applications require singleton as such in code. But if you think about like string framework or J2E, right? Like log4j as a program, the utility classes, the language classes, annotation, some of these are like singleton classes, which are a part of the framework. So you don't have to write your own singleton classes, like these libraries or these annotations, these utilities or singletons will do one job in your application and you can use them. So it's very rare for programmers to actually like create their own singleton classes at this point. Next is very widely used creational design pattern, which is factory pattern. So this is basically, like, you can call it, like, you can understand this as a factory that creates objects, a factory of objects, right? Like there's a vehicle factory, it just creates vehicles, right? You have this one template of how the vehicle model, make, style, year looks like. And what you are doing is your factory is just generating more and more vehicles of that kind, right? So the template of your vehicle design is a class, and every new vehicle you create is an object, right? It's an instance of that template. And your manufacturing factory is just creating more and more objects, more and more vehicles, right? So that's one real life example. That's how you can think about this pattern, right? So you create an object, but you hide the object creation logic. So you don't know how the vehicle is manufactured. All you know is there's a factory that creates the vehicles, right? That manufactures the vehicles. But you don't know how exactly the manufacturing or creation process looks like, right? So we looked at interfaces, right? Like just some time ago. Interface is what is used here to actually implement this factory method, right? So we'll look at the code a bit later. So you create any instances on demand, and you can initialize the fields the way you want, right? You can initialize different fields, you can initialize all fields, less fields, depends. And you can create different types of different instances of the same class. This helps you reduce code duplication, right? Like you don't have to write the creation logic, the initialization logic per object. It just goes into this one factory class, which does the job for you, right? And if there are classes or objects where there's a consistent behavior, right? Like every person has a name, every person has an age, every person has an address, then you can use that factory method to create every instance of person, which has 3 basic data points and 3 basic methods to get the age, set the age, the name, the address, etc. Right? So this helps you keep consistent behaviors across objects of the same type or classes of the same type. And this helps you maintain the classes and somewhat centralize the creation logic, right? So your factory does takes care of creating objects or classes of the same type. So you're somewhat centralized what that creation logics looks like, right? This helps to also like create like loosely coupled classes, right? Like for example, to the right, we have Uber users. You can be a rider, right? A passenger, someone like you and I is taking the ride, and you can be a driver, right? Like you are actually driving the vehicle, the Uber vehicle, right? Both these users are different types, if you think about it, but they have same attributes like name, age, and location. But if you see, the rider has the rider ID, some payment information, some home address, right, work address, some location history, ride history, some credits and offers. But the driver doesn't have all of this. Like there are only few similarities, right, between these two objects. But the driver has a driver ID, the number of hours they drove, what is the rate per hour, let's say, or what is the salary, or what is their benefits they get as an employee of Uber, right? So you have created two different types of users here, which have similar methods, but they also have their own specific data points and methods across for that type of class or that user, right? Another example we already looked at, like the shape. Every kind of shape will have the formula and the name, but like how you actually are calculating the area, or if there are any other things that you're doing in that shape can totally differ. But anytime I create a new shape, I am making sure that it has the area and the name in it, and it has the methods to calculate the area and the name, right? So creating a new shape or creating a new user is just standard, right? They will have similar functionalities, and the data is at the very basic level. Some very basic data is initialized every time an object like that is created. So if we look at the code, the factory pattern. So here, right, same example, shape. Every shape will have a name and a formula, right? Now we have a shape factory, which we will call this method to create the kind of shape we want. So if I'm specifying that I want so I created, let me step back. I've created this name enum, which has values circle, triangle, and rectangle, right? I can add more shapes here, right? Because these define all the shapes I have in my system. And what my shape factory does is, if you ask me to create a circle, I'm going to check if your input is a circle, then I'm going to create a new circle object and return it to you, right? If you're asking me to create a triangle, then I'm going to create an instance of the triangle class and give it to you. If you're asking me to create a rectangle, then that's what I'm going to give it to you, right? So this is your factory. You can specify the shape you want, and it will create that for you. And if you look at the circle class, it will initialize it will make sure that when you call these methods, it will only return this compared to a different shape, right? So how the circle operates, how the circle class operates is structured here. But when you are telling me to create a circle class, everything related to a circle would be here, right? So this is the factory. This factory is creating objects of different kinds is centralized to one class, and you can tell this factory to build or create any kind of shape, and it's going to do that for you, right? So if you look at the factory initializer class, right? So I created an instance of the factory, and I'm telling it to create a circle, right? I'm telling it to create a triangle. I'm telling it to create a rectangle. So now I've created 3 different kinds of shapes using the same factory, right? I specified the shape, and it's going to tell me, you created a circle which has this area, or you created a right angle triangle which has this area, and you created a rectangle which has which this is how its area is calculated, right? So creating an object, you can create as many objects as you want. If I create another circle, another triangle, another rectangle, and just print their formulas, then I'll still have two different instances of the circle class, right? Which have the different name, but they all have the same functionality. Right, so very easy to structure creating objects of different kinds in a centralized manner, and easy to maintain. If I add a new shape, then all I have to do is I have to add another check here. If it's a polygon, then you return an instance of a polygon shape, which will have a very different fields, very different way of calculating the area, right? Depending on the sides and everything. So very simple, very structured. And easy to maintain, because you have to look at only one factory class which does the initialization, the creation for you, right? Last but not the least is a builder. I would say this is also very, very common, probably most used creational pattern. So this helps us build custom objects of a class, right? Every object, let's say I'm creating 3 different objects of this one class. Every object can look different. The fields that I initialized in every object can be different. They may not be the exact same, right? You can use the same creation, same centralized creation logic to create that object, but how they're initialized can be different. They can be custom objects of the same class, right? That way you separate out the construction and the representation, right? Because you're constructing it from one location, every object, but each object can look different, can be custom. So the way the object representation looks totally different, right? This helps you give like a flexible design. It helps you provide like a more readable code, and you have more complete objects, right? Like if I'm creating a custom object, it's a complete object in itself. I only care about 2 fields, right? I don't care about all the 5 fields. But if I only initialize 2 fields, that object is still complete in itself. It's not incomplete because the other 3 fields are not initialized. One example can be like ordering food from DoorDash, right? If you order the food from DoorDash, let's say chicken combo, you need to specify which fries you want, right? You can select here, if you look at the image, I can select the Kajuri fries, but this is the just one option that I need to select. But if you see, there are options to select. I want like a napkin and utensils, or I want a Coke by the side, or I also want this dessert. You can select that. So every time I add an item to my cart, for certain items, I can just select what I need to and not add anything else. But for a different item that I add to the same cart, it's still a new order, right, that I've created, but it may have a new item that I've added, but it may have like I selected Coke for this, or this other item that I added to my cart, I selected dessert. So you're creating the object the same type, right? Like selecting an option from the menu, but what other options you select with that one main option can look totally different. So let's say one example here is an employee class, right? You can create 3 different class. If you see the diagram, 3 different objects for the same class. One object only has first name and last name. So you can create an employee class with first name and last name only, right? You can also create an employee class with the department and the manager specified. And you can create an employee class with all of the above and their address, right? They are still all valid and complete employee classes by themselves. Is that there certain fields are initialized and certain fields are not initialized. So if we look at the code for builder pattern, so here is my employee class, right? I have first name, last name, the address, and the department of that employee, and then the manager name, right? I can initialize, so I'm using constructors for this. I can initialize this is very basic. You can have your own like builder class, but this is a very basic implementation of builder class, which is easy to understand. So I'm using a constructor here to create an employee which only has first name, last name. I'm adding this another constructor which also specifies department and manager, and I'm adding this one third constructor which initializes everything that I have in my employee class, right? And which only has first name, last name, and address. And the fourth one has everything that I can initialize in my employee class. And yeah, and if I run the builder initializer class, if you see, I've created 4 different types of employees. The first employee only has the name, first name, last name. The second employee is still as an object, right? It's still an instance of the employee class, but the fields that I have initialized are very different, right? But this employee class is complete in itself. If you just give me these 4 data points, I will still call it an employee, right? It's still a valid entity in our system, right? It just has the names and the department and the manager. The third instance is names and address. And the fourth one is everything, right? All the data points I have initialized. So if I just run this program and I create 4 different objects, custom objects of the same class, then you will see this employee was created with first name, last name, and all the other fields were initialized to null. If you see the second employee names and the department and manager name. The third employee has the names and address, but the department and manager is null, initialized to null. And the fourth employee has everything, the names, the address, and the department and the manager. So these are still very valid employee objects. They are just custom. They are just, you have more control over how that employee object looks like, and you can do different operations, right? Like for example, on this employee, if you try to get their department or manager, you will get a null. So this the employee is still enrolled in your, let's say, company, but they are not assigned a department or a manager yet, right? They are still onboarding, one example, right? So you still don't know what this will look like, right? Maybe they are remote, or maybe we are opening a new office. So at that time, they'll be assigned an address. So then therefore right now their address is null. We would want to associate an office address later on, something like that, right? These objects can evolve. They can have, these custom objects can have their own life cycle across your application, and you can do different validations and data manipulations per object. But these are very valid, complete objects in themselves, even though the data points are not all initialized, or all the data for every employee we may not have at a given point in your system. Yeah, this was it for a very basic, very simple demonstration of some of the top creational design patterns leveraging object-oriented programming. Do we have any questions? Feel free to unmute or just put it in the chat. Yeah, thank you, Gina. I have one question from Monique. In the beginning, in one of the slides, I mentioned the technical tracks. Is there one behind backend engineer? One around about backend engineer. So Backend Study Group is more like a series. It's not a technical track. I can Elaine or Aditi can chime in, but my understanding is that these tracks are their own curriculum. Backend Study Group is something we are trying, so we have not come with a structure yet. It's just the third session right now. So maybe in the future, but we are just trying out a series of sessions to begin with.
Yeah, just to add here, the technical tracks that Prachi mentioned earlier, there's no backend specific track yet. This is our efforts to start more focused talks around backend series. But yeah, you can, at least right now, there's no like official track for backend engineering. But if you go to our WWCode YouTube channel, you will see a lot other networks as well doing backend related events. Which are recorded recently. So if you want more content around backend or even the digital mailing list that Prachi shared, that will show you upcoming events if you want to attend more backend related events. Hope that helps.
Yeah, another question I see is, are they Java specific? Well, not really. There are design patterns for C++, any other object-oriented programming language, and also for Python. The patterns may look slightly different. I'm not familiar with all the design patterns for Python or C++ to say, but they can slightly differ. But if you understand object-oriented programming as a base, then trying different design patterns for different languages should be fairly simple to understand. Yeah.
I'll jump in on that because I've been doing a lot of OOP in Python, and Python is a lot more forgiving. Like it's a lot of, like for example, if you put an underscore in front of a method or an attribute, it's like understood to be private, but anyone can access it anyways. And so I think learning something from like a more strongly OOP language like Java, where you have static methods and you have abstract classes and you have private methods and they're actually private, is very good training, because it has been helpful to me to like tell my team and my job that, oh yeah, underscore means like don't touch it, don't use it, and that helps a lot. So Yeah, I really, I think this is what Prachi has presented goes across languages. It's just good design practice.
Yeah. The way I structured this session was you have to get into the mindset of how to think about design. It's just not like you have to understand, oh, I know all the OOPS principles, fine. I did a tutorial online for 3 hours and I know everything I need to know about OOPS. Well, not really. When you think about, when you do all this coding practices and when you think about design in general, is when you'll understand object-oriented programming, you'll understand how these design patterns are actually leveraging the core 4 principles. There are more principles, but these 4 are core to actually come up with this design pattern. And pick up any domain and you will be able to be more intuitive or simply understand what pattern works here best and what pattern does not. And given that our application may scale in the future, we may have more features, more kind of data, maybe this is a better pattern choice than this is something else, right? Like if you have different kinds of users that need to create and there are many users, right? Like there are many employees in your company. You cannot use a singleton for creating an employee class. You can use a singleton, let's say, for the CEO, because only you have one CEO. But you need a factory or a builder class to create many objects of many types of users and many employees and many instances of those employees, right? Like there can be software engineers, there can be HR, 2 different type of employees, but there can be many software engineers and many HRs at your company. So you have 2 different kinds of classes and many objects, right? So using a factory or a builder pattern is better than singleton. It just doesn't apply. It just doesn't give you that solution in this case, in this example. Yeah, Monique asked a question, will you be able to access the slides? So let me share, am I able to see the, yeah, here. So this is the Women Who Code Study Group GitHub repo, which I think Elaine shared, but I'll also share one more time. You will see here, this is the design patterns demo. This is the code of what I presented today. And you can see all the classes and README and everything here. This is Student Management Services, a demo of basic microservice REST API and database from our last session. And here is the meetup events. So the first meetup event, the second meetup event where I added the slide and also all these different screenshots of the API, the database, everything related to the code. And here I'm going to create a new folder and I'm going to upload today's presentation, the slides. And I think in a week, the meetup event for today's session, Elaine, I think she'll also upload the YouTube recording of this session. So you can also refer that.
So I can take the next question, which is about, which is from Darcy.
Yeah.
So just to clarify, the design patterns and the object-oriented concepts, all this is part of computer science in general. It's not language specific. So each language will have a different implementation of these design patterns, and those can be language specific. Today, Prachi showed us what is Java specific implementation of these, but these concepts are all very generic. It's applicable across different languages, even if I don't know about Python as much, but I can talk about JavaScript. That is like, it doesn't have classes as a concept, but it has a similar implementation so that you can adapt or you can talk in the similar language when you're talking about those concepts in JavaScript. So the languages may adapt according to what that language provides, but these concepts are all generic in computer science.
Yeah, some things like here, right? Like make sure that your code is reusable. Make sure that there is a relationship between different objects or different entities of your code, right? These are some, like, make sure your code is flexible, maintainable, right? These are some basic benefits of like basic things you want to achieve in your application, right? These are some basic principles or standards or practices you want to keep in mind as you design any kind of application in any kind of language, frankly, or any framework for that matter. I have Darcy says, can you do an implementation of this concept in Python for next session? So I'm not completely familiar with Python. Therefore, no, not in the next session. But if there is a need, then we can have a similar design pattern session just in Python, implementation in Python. Just like select a few top design patterns and do a Python implementation of them. Yeah, it's an idea, sure. Something that we can keep in mind. Yeah. Lastly, what's the name of the book that you referred? Monique asked that. It's here, Head First Design Patterns. There are many design patterns books, but this is much more intuitive. There's a lot of good amount of visualizations. The language is pretty simple. So if you're beginning, just go with Head First Design Patterns book. Is there a syllabus or series of topics we are covering in this study group? So yeah, we talked about creational design patterns. Structural would be next, top structural design patterns, top behavioral design patterns, then anti-patterns and interview questions. So if we look at this here, right, we talked about creational, the top ones or the most used ones, and structural is what we'll talk in the second session. The third session would be behavioral, and then anti-patterns, and then interview questions, which will include the theory of the theory as well as code. And there are lots of resources online that you can refer for design patterns. Some of them I mentioned here in the link in the slides, which you can refer to. I think these are more simple implementations or understanding of design patterns, which I would recommend. Very simple and easy to understand tutorials, I guess. Yeah.
Also to add to this, so we are still like in early phases of starting this series. So we are just adding like few sessions at a time and thinking about few sessions at a time. Long-term goal is to do more system design. So we are building on this basic blocks, and that's our plan for the next, like at least for the next 4 sessions, we are focusing on design patterns, and then we'll add like do like additive sessions that would lead to ultimately do more system design conversations later on.
Yeah, like designing a database or designing a microservice or designing, I don't know, a distributed system. There are many things. It's such a big topic, but we started with just a first session where we talked about what backend engineering is, right? And then the second session was just a demo of how to create a microservice, REST APIs, and a database, very basic. And that helped us understand like what are the 10 things that a backend engineer thinks about and does, right, in their day-to-day. And the third session is like, we have to talk about design because this is a building block, right? Like if you ask me to design Chipotle, like where am I going to begin with? Like what am I supposed to do, right? Like I'll probably start with the design, like what are my users? What does my data look like? Are there any consumers, right? Like, yes, fine. Then like I'm going to talk about how am I designing my service. So like there are a lot of things that go into it. We are starting with design, the concepts here at the very basic, and then we'll move on to more system design, the theory of it, the some of the standard solutions, interview questions, right? Like design at Chipotle, we can talk about it for an hour on how to design it, right? Even just a general conversation, forget about I drew something and I wrote a code. That's a whole different level, right? So there is a lot. And if you can just, Elaine shared the feedback form. If you can just fill that for us, it will let us know how we are doing. And if there are any topics you want to talk about, right, just like mention there so we can plan for them, right? It will give us some time to structure and continue this backend study group. Yeah, thanks Elaine for sharing the form. We also have the Slack channel for the backend study group. So if you have questions, you can ask in that channel as well, and we can answer your questions. We can share some resources. Feel free to leverage the Slack channel for all your questions, if you have any later on. Yeah, thanks, Elaine, for sharing the channel, Slack channel information. I think we'll stick around for another 5 to 10 minutes. If you have any questions, to unmute and ask or put in the chat, or use the Slack channel as well. And the recording, I'll upload the slide right after the presentation, this call. And I think in a week, Elaine will share the link of this YouTube, this recording on the Meetup event page, so you can reference it. Yeah, thank you, Monique, Gina, Darcy, Michelle, Martina. Thank you, everyone.
Yeah, it looks like we can stop the recording.
Yeah.
Thank you, Prachi.
Yeah, thank you.
Thanks. All right, I'll stop it.